Hey everybody, EduCats here. Welcome to my channel. In this video, we're going to be taking a look at 2D vector questions for Year 11 Physics. So let's get to it. A cross-country runner runs 3 kilometers due east, 5 kilometers due south, and 8 kilometers southwest. What is the runner's final displacement? So displacement is a vector, and to work this out, we have to do vector addition. Now, the first place to start is to draw the directions to give us a sense of bearing. Now, we do north, south, west, and east. So excuse the messy diagram. And then we're going to draw the different vectors. So firstly, they run 3 kilometers east. So 3 kilometers. Then they run 5 kilometers south. And then they run 8 kilometers southwest. And then we're asked to find the resulting displacement vector. So I'm going to start labeling some of these vectors. So I'm going to call the resultant to be VR, and I'm going to use a squiggly line to designate that it is indeed a vector. I'm going to use V1 here, V2, and V3. And in addition to this, for V3, we know it's southwest, so we know that the angle it sits at is 45 degrees. So we make this assumption because they didn't specify in terms of how southwest it is, so we're going to make the assumption it's exactly dead in the middle, 45 degrees. Alright, so to work out any vector question, the resultant is always the sum of the component vectors. So in this question, it's V1 plus V2 plus V3. Alright, so the reason why this question is a little bit tricky is because in the most common types of questions, the easier questions, you're only asked to add 2 vectors. Typically, they're completely vertical or horizontal, and then you just do a little bit of Pythagoras. In this question, we don't have that. We have 3 vectors. 2 of them are either horizontal or vertical, but one of them is a little bit in both. So how do we do this? We're going to be doing this by breaking up the individual vectors into x and y components. Okay, so we're going to use a slightly new notation you might not have seen before, but it's totally valid. So we're going to say x is x direction unit vector. So we're going to say it's positive this way, east. We're going to say x vector is the x direction unit vector, and it's positive in the east direction. So we say this is positive, and then we say y vector is y direction unit vector, and we're going to say up or north is positive. So we can say this is positive. And so right now, because we've set the convention, you will be marked correct with your working out. Now, let's start with the first vector. Let's start with V1. So let's take a look at it. So remember, V1 is 3 kilometers in the easterly direction. So because it's purely in the horizontal direction, we don't have any y, but we do have an x component. So all we write is that it's 3x unit vector. Now, it points in the east direction, so we know it's positive, so we're done here. Let's move on to V2. V2 is completely in the south direction, so it's completely vertical. That means we have no x component, but we have a y component. So we have 5 in the y component, and because it's south, which is in the negative direction, we have negative 5y. And now we're going to use V3. We're going to work out V3. So V3, let's draw V3 separately. So I'm just going to change colors here. Alright, so this is V3. And V3 is made up of v3 is made up of v3, you can think of this as v3y and v3x, and this is v3. Now, what do you do to work this out? So, in order to work this out, you need to do a little bit of trigonometry, but it's easy trigonometry because it's right angle trigonometry. So, if you have to work out the x component, which is this component here, you know this as the hypotenuse, and this is the adjacent, so you have to use cos. So you do, the units, this is 8, so the magnitude is 8, and then you do cos 45 degrees, and this is the x component, so we're going to say x like this, x unit vector. Now let's work out the y component. So I'm just going to write it at the bottom because I'm running out of space here. Now, if you want to work out the y component, which is this component, you do, the y component is also the same here. You have to take a look at this as hypotenuse, and this is the opposite to this angle, so you have to use sine. So you have to do 8 sine 45 degrees y. Okay, so we're not actually done here. So this part of it, if you look at the y component, it points in the south direction. And remember, south is negative. So we have to put a negative here. So I'm just going to put some brackets to make this a little bit neater. And now in the first part, the x part of it points in the westerly direction. And remember, west is negative as well. So I'm going to have to put a negative here. And I'm going to put some brackets here to make it a little bit neater. All right. Now we're actually ready to get the final answer. So remember, v resultant is the sum of all of these vectors. Let's just substitute these directly in. So we have 3x here, minus 5y here, minus 8 cos 45 degrees x, minus 8 sine 45 degrees y. So because these point in the same direction, so all the x's point in the same direction, the y's point in the same direction, you can add them directly. So really, this question breaks down into 3 minus 8 cos 45 degrees. So I'm just going to put some brackets here, x direction, and I'm going to say plus, and then put another bracket, and we're going to say negative 5. And you look at the other y's, which is here, 8 sine 45 degrees, and then y vector. Okay, so now all you have to do is you just have to take out your calculator, because I can't just work this out in my head. I think it's 1 over root 2, but my calculator will verify that. So we do 3 minus 8 cos 45 degrees, and I get the answer of negative 2.66. So I'm going to do 2 decimal places, and then I'm going to put a plus here. So I'm just going to put some brackets here to make it a little bit neater, and then I do negative 5 minus 8 sine 45. I get negative 10.66. So that's to 2 decimal places, and then y vector. All right, so that's technically your answer, but if you want to find magnitude, remember, all you've really done is you now have a vector that's completely in the x and the y component, which is a 2D vector. So if you were to draw this out, as a triangle, you would have, say, okay, so this is negative 2, so we go in the westerly direction, so we say 2.66, and then we have negative y, so we have in the negative direction 10.66 here, and then to find out the total, the resultant, you just have to apply Pythagoras. So you can say, so let's continue this line. So you can say this is equal to negative 2.66 squared plus negative 10.66 squared square root. So this is Pythagoras, and essentially you're working out the resultant, which is made up of an xy component. And if you pull out your trusty calculator, 2.66 squared plus 10.66 squared, and then square root the answer, I get 10.99. And I say to 2d dot p, 2 decimal places. And so my original units were in kilometers. So remember, units are an important part of it. You will lose half to 1 mark for this. So 10.99 kilometers, but that's only part of the question. Remember, we have to also work out the angle. So our vector points this way, and I'm gonna use, okay, so I'm gonna be going from south to west. So I'm gonna work out this angle here. So to work out this angle here, theta is equal to, okay, so you know the opposite, which is 2.66, and you know the adjacent, which is 10.66. So you do inverse tan of 2.66 to 10.66. So you notice I totally ignored the positive and negatives because the diagram dictates the direction for me. So all I really want is an acute angle. So in these kind of cases, you can just totally ignore the positive negatives here. So inverse tan 2.66 divided by 10.66, I get 14.01 degrees. Okay, so what does this mean though? So 14.01 degrees, however, this is in the south direction and this is in the westerly direction. So I say south to west. And that makes it perfectly clear at what angle you're going from. So overall, let me just change my pen. Your answer is 10.99 kilometers at 14.01 south to west. So as a recap, to do these kind of questions, you can break down any individual vector into the x and y components, which really just represent horizontal and vertical. So if you can get used to this notation, it doesn't matter how many vectors you have. You could have 3, 4, or even more than that, and you can add them up in completely different order. So I did v1 plus v2 plus v3, but you can completely mix that order up because it's addition. And you break them up individually into the components. You substitute it to work out the resultant. You add like terms, and once you have the x and y components completely as one term, you can apply Pythagoras to work out the magnitude, and then apply simple trigonometry to work out the angle for the resultant vector. So I hope this has been helpful. If you'd like to see a more graphical approach, which all you need is a ruler and a protractor, and you can get a pretty accurate answer, let me know in the comments and I'll create a video for that. Thanks and bye for now.